be trying fixing something, and instead of GPT-4 we'll be using Gemini to fix this code. It seemed to know a lot about developing Flask applications and stuff, so let's get to it. Just open another chat. Okay, so we have what do we have? So it's a Flask application, obviously. So we have Flask code. We have the index HTML that we need to fix. And now importantly, this CSS is for the entire project. And not can just leave that. Yeah, we'll add that CSS in a bit as well because it's very important. Let's see what the JavaScript files we're calling for. We're calling for script. Is it main.js or script.js? Okay, again, the script.js is for the whole project as well. It's the menus on the website. And we have the main.js. I'm calling a bunch of JavaScripts, but let's start from here. Yeah, we need to fix this styling on the website pretty much. And yes, we're using Copilot as well. Yeah, we do real-time parameter adjustment, that's fine. Split mode, yeah, that split mode view is problematic. Pulseness, yeah, whatever. Refactoring the code. Don't think we need to do that one yet. Okay, we don't need to refactor the JavaScript code yet, but below is the CSS file for the whole project. We need to sort out the styling. Something is currently wrong. Oh, come on, why is it deleting? When you hit the microphone button, it gets deleted. Okay, I have to do it manually. Let's pull out a style file for the whole project. Oh, this button is so annoying. I just got used to the OpenAI's one, but that was some sort of add-on. It wasn't OpenAI, it was an add-on in Chrome for OpenAI website. Oh, annoying. Get the CSS below and the current HTML that I just shared. Are there any issues with any IDs not included or not interacting correctly? Yeah, suspect there's something happening between the two files. Header navigation, yeah, that's fine. Responsive images doesn't seem to use it. No, the responsive images is not that. Additional style considering object feed, response, no, new styles, image style, max, blah, 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 text section, blah, blah, minor issues, image grid. Um, no, it's not getting the whole context. So as I mentioned already, this CSS file is for the entire project, and I want to keep just one CSS file for the whole project. I don't know how to add more. The microphone doesn't work. If you hit the microphone again, it just deletes the whole message. Performance. Yeah, I need to adjust those parameters for it to work better. No, it doesn't work better, does it? Yeah, it's playing up. Should be some sort of procedure as to how to. It's not quite finding. Maybe this is better. Yeah, there will be some sort of a better value considering the light conditions in the room and things like that. Blah blah blah. Yeah, that's not what I was asking for. Okay, can we go back to the original HTML and the main JavaScript file? We would like to fix the styling from within HTML or JavaScript if necessary. Might consider removing the split view for now as well. The canvas is currently overlaid over the text. We need to fix the canvas, both the video and the eye tracking canvas to work better. Let's just manually. Yeah, how do we check for IDs? There's some command, terminal command that could find the old IDs in HTML, but I forgot what it was. Okay, now it's now we're getting somewhere. remove the split view. Yeah, I might get rid of it. It's the one that does that, but I suspect it's just causing, don't really need it, makes things complicated. Just potentially it's causing issues as well. A checkbox split view and its ID is split view toggle. Search for it. Flex, flex, flex. Yeah, this, because this is messing up potentially. Messing up styling for the page. Okay, now it's not working. Why? Okay, now it's working when I click on it. Yeah, the two pages meant to be overlaid. Let's check the HTML again. Yeah, we have the video canvas. They are the same size. Video container. Okay, so I commented out the code for split view toggle, but couple of things. We need to make sure that the canvas and the video are overlaid on top of one another at all times. Okay, let's edit that. So there is no CSS file. I probably shouldn't have shared that file. Forget the CSS file. All styling show off for tracking canvas and the video should be controlled in HTML and JavaScript. Make sure canvas is overlaid on top of the video all the time. I'll pop it in there as well. Let's do JavaScript and the HTML with that prompt. And while it's generating, go check out biomedical.com. Where's my chat? My chat just disappeared. From OBS. That's not cool. To actually go into YouTube to fix it. Yeah, let's read this quickly.
Absolutely. Let's get the styling for the video and tracking canvas handled directly within your HTML and JavaScript files, ensuring the canvas consistently overlays the video. Add style attributes to the less than video greater than tag to set its position to relative, width and height to 100% to fill its container, and z-index to a lower value, e.g., 1, to ensure the canvas is above it. Add style attributes to the less than canvas greater than tag to set its position to absolute, ensuring it overlays the video. Set its top and left to 0 to position it in the top left corner of the container, and its width and height to 100% to match the video size. Also, set the z-index to a higher value, e.g., 2.
Okay, there's something is not quite right, is it?
Optional, dynamic sizing. If you want to make the video and canvas responsive to the window size, you can add JavaScript code to dynamically adjust their width and height attributes when the window resizes.
Okay, there's something. Looks like one of those filters in whatever Instagram or TikTok. Come on.
Delete any styles you added previously to hashtag video container, hashtag video, and hashtag tracking canvas. We're now handling these styles inline in the HTML.
Okay. This would be better. However, yeah, we need to delete stuff from it's called, yeah, all those IDs. Okay, the video container did remove that from JavaScript. A video element ID.
Simplify styling. No more separate CSS for video, canvas positioning. It's all in the HTML. Guaranteed overlay. The canvas is always positioned on top of the video due to the Z-index values. Responsiveness. Optional. You can easily add JavaScript to make the elements resize dynamically with the window. Additional notes. If you decide to reintroduce the split view functionality later, you can control the video and canvas layout using JavaScript to toggle their style attributes or CSS classes. If you have a reason to keep the video and canvas size fixed, not responsive, remove the width and height attributes and let the browser handle them based on the video's aspect ratio.
Something is up. Can't even use the controls or anything. Very odd. Something. Something seems to be interfering with the overlay. They are not the same, what's called, aspect ratio. There's something wrong with the aspect ratio between the video and the eye tracking canvas. Here is an image uploaded. Should be able to just copy paste. Related issues. The HTML make sure a tracking canvas and the video have the same, the original. Aspect ratio, I think that's what it's called. So we're adding this to the prompt, including an image. Yeah, obviously the canvas, the eye tracking canvas is being stretched. While it's generating, go check out the biomedical.com. Will be lots of interesting tools. This will be the most recent one. Is that the life simulator? Go check it out. I can't paste it into the chat. Yes, I can.
You're absolutely right. The aspect ratio of the video and canvas is indeed off in a provided image. The issue arises because you're setting fixed width and height attributes on both the less than video greater than and less than canvas greater than elements in your HTML. This forces the elements to be 640 by 480 pixels, regardless of the video's actual dimensions.
Okay. Yeah, we need to maintain the original aspect ratio.
In your
Yeah.
index HTML file, remove the width and height attributes from both the less than video greater than and less than canvas greater than elements.
Oops.
In your styles.css file, add a style for hashtag video container to set the aspect ratio based on the video's intrinsic dimensions. You need the original width and height of the video to calculate this.
Yeah, could be nice for mobile devices if you have a non-standard screen and things, but it should be like a separate issue, is it? Okay, where's the... Yeah, the canvas is out of whack. Yeah, we definitely don't need that. Yeah, we don't like the... Just happened there. It is obviously...
You're absolutely right. The aspect ratio issue often arises when we force the video and canvas elements to occupy 100% of their container's width and height, without considering the video's intrinsic dimensions. Remove all inline styles related to width and height from the less than video greater than less than canvas greater than elements. Add the following code inside the video element, on loaded metadata event handler. This code does the following. Gets the intrinsic width, video video height, of the video once it's loaded. Calculates the video's aspect ratio. Sets the container's width to a fixed value. You can adjust this as needed. Calculates and sets the container's height based on the width and aspect ratio, ensuring the container maintains the correct proportions. Sets the canvas's width and height to match the video's dimensions, ensuring perfect overlay. By removing the fixed width and height attributes, we allow the video to take its natural dimensions based on its source. The video container acts as a wrapper, controlling the display area for both the video and the canvas. We calculate the height of video container using the video's aspect ratio to maintain the correct proportions and prevent stretching. The canvas is then resized to match the video's dimensions, ensuring that it perfectly overlays the video with the correct aspect ratio. Key points. No CSS required. We achieve this purely through HTML and JavaScript, eliminating the need for separate CSS rules. Preserved aspect ratio. The video and canvas will now maintain the correct aspect ratio, regardless of the video's original dimensions or the container's width. Responsive. If desired, you can easily add an event listener for window resizing to adjust the container's width dynamically and recalculate the height based on the new width and aspect ratio. You are absolutely correct. Even after removing the fixed dimensions, the canvas might still get stretched if the video container doesn't have a fixed aspect ratio. Here's the updated code with fixes to ensure the video and tracking canvas maintain their original aspect ratio, all controlled within your HTML and JavaScript. Dynamic element creation. We now create the video element and canvas elements dynamically within JavaScript after the video's metadata, including dimensions, as loaded. This ensures we have the correct aspect ratio information before setting up the layout. Aspect ratio preservation. The aspect ratio is calculated based on the video's intrinsic dimensions, and the video container's height is adjusted accordingly to maintain the correct proportions. Inline styling. We apply the necessary styles, width, height, positioning, z-index, directly to the video element and canvas using JavaScript. This eliminates the need for external CSS rules. Timeout removed. The set timeout function has been removed since we are now creating elements after the video loads. Key points. The video and canvas will now always maintain the correct aspect ratio, regardless of the video's original dimensions or the container's width. No CSS is required for video and canvas styling, making the code more self-contained. You're absolutely right, the previous code had a small bug. The video container element wasn't selected before attempting to append the video element and canvas to it. Let's fix that.
Like it, the previous code had a small bug. The video container wasn't selected before attempting to append video element in canvas. Let's fix it. So in JavaScript, I do oops. So the element I added from within JavaScript, are they? Okay, I'm pretty sure I don't need that, but I'm still not sure about this one.
The line const video container equals document. Get element by id, video container, was missing, which is essential to get a reference to the container before you can append children to it. Additional tips. Browser compatibility. The unloaded metadata event is widely supported, but you might consider using a polyfill for very old browsers if needed. Video not found. If your video doesn't have a src attribute, you won't get valid video width and video height. Ensure the video source is set before you calculate dimensions. Error handling. Consider adding error handling in case the video fails to load or its metadata is unavailable. With this fix, the video in Canvas should now be correctly appended to the container, ensuring the canvas overlays the video with the correct aspect ratio.
Line 64. Sure, so we're not loading it into HTML first.
Absolutely. This type error cannot set properties of null. Setting src object error means that the start video stream function in your video stream JS file is attempting to set the src object property of an element that hasn't been found in the HTML.
Well, yeah, because it told me to remove it. Okay, they're not overlaid. Let's remove this for a sec, assuming just made a mistake. Yeah, the eye tracking canvas is at the bottom there. Okay, this function is in the video stream.js. It's getting more and more complicated. Why? It should be fast. I thought let's start a new chat. Come on. Okay, I have a flask. We have a main.js. Yeah, all the prompts should be there already. Now, problem is main.js. We have video stream, face detection, face model. Might need video stream. We also have drawing utils. Yeah, I have a lot of stuff. Let's see if it can manage it all. I don't know how this became so complicated. I don't like files like that that only have a few lines of code. Is this correct? Yeah, I assume so. Should know about them anyway because they've been called from main JavaScript. While it's generating, go check out biochaos.com. There's a lot of interesting blogs that you might like. Do let me know what you think.
Video and canvas overlays. Remove the split view toggle as requested. Adjusted the video and canvas container styling to be more responsive and ensure they overlay perfectly. This is now done directly within the unloaded metadata event handler in main.js. The video container now manages the layout using Flexbox or block display based on screen orientation.
I need to rewrite the whole thing.
Aspect ratio preservation. The code now calculates the aspect ratio of the video and applies it to both the video element and the canvas, ensuring they maintain their original proportions. Canvas rendering. Simplified the canvas context creation. CTX equals canvas. Get context, 2D, will read frequently. True, styling, HTML and JS. The CSS file is no longer needed. All styling for the video and canvas is now handled in the HTML, video container, and JavaScript, main.js. Pupil detection. Added comments and console logging to detect pupil to help you understand and debug the process. Added darkness underscore threshold, red underscore coefficient, green underscore coefficient, and blue underscore coefficient to detect pupil function.
Just generated the whole code. Okay, the main functions seem complete. 167. Yeah, we still needed the CTX there. Maybe not. Can get rid of those. Now detect and draw. A request animation frame. Catch error.
Clearer structure. The code is now more organized and easier to read. Responsive overlays. The video and canvas elements will always be correctly overlaid and maintain aspect ratio. Optimized canvas access. The canvas context is created with the will read frequently flagged for better performance.
What's the
Error handling. The try, catch blocks help you identify and troubleshoot potential issues.
video elements not defined? 130. Have video element ID. Should we give it to a GitHub Copilot? Yeah, the video element ID. Should I just take it outside? Just take it out here. Oops. Come on. CTX, yeah, this meant to be outside that function. Probably. Okay, we have the video. Yeah, we have the canvas. It's not overlaid. And video not overlaid. As we any styling. It's okay. We only have one HTML, so
You're absolutely right. Here's the corrected main JS along with adjustments to the HTML to resolve the overlay issue.
Do we trust it or not? It keeps bringing the canvas and CTX into the main function. In HTML. Okay, I think we're missing something.
Model loading. The Blaze phase model is now loaded before starting the video stream. This ensures the model is ready when the video starts. Positioning. The video container is now given position, relative. Both the video and canvas elements are positioned absolutely within the container. The canvas has a high Z index to make sure it's always on top of the video. Video muted. The video element now has the muted attribute to avoid potential audio feedback when testing locally. Explanation. Load model. We first load the Blaze phase model so that it's ready when the video stream starts. Start video. We start the webcam stream and wait for the unloaded metadata event. Set dimensions. Once the video metadata is available, we get the dimensions and aspect ratio, and set the width and height of both the video and canvas elements accordingly. Position overlay. We position the video and canvas elements absolutely within the video container, and make sure the canvas is on top using Z index. Start detection. Finally, we start playing the video and call the detect and draw function to begin the eye tracking process.
Okay, we're going in circles now. That's not fun anymore. That's not fun. Just try the arrow by itself, but I have a feeling It just like randomly stuffs things up. Oops. Was able to fix the previous errors.
You're absolutely correct. The error cannot read properties of undefined. Reading height at line blazeface 17 to 5285 indicates that the blazeface model is having trouble processing the video frame you're passing to it. This is likely because the video element or the video frame is not fully loaded or initialized when you try to access its height property. There's something wrong with the camera now. It's the camera. Get it now overlaid, but the canvas is not updating. A canvas is not updating. Make sure tracking canvas and video are overlaid. Make sure a tracking canvas is transparent. Well, it is transparent. That's good to have. Make sure the tracking canvas is always on top of the video. That's good to have. Make sure tracking and the video have the same aspect ratio. I think we tracking canvas is updating live with the video. It's able to solve some problems so far. So far so good. Got it. Here's the updated main. JS along with HTML changes to ensure the tracking canvas overlays the video correctly, is transparent, stays on top, and updates live.
Let's check HTML first. Autoplay muted. Okay.
Canvas transparency. Remove the fill style from draw bounding box. No longer clearing the entire canvas in detect and draw, now just clearing the previous frame of the video. Canvas click through, added canvas, style, pointer events equals, none, the unloaded metadata event handler. This makes the canvas transparent to mouse clicks, allowing you to interact with the underlying video, if needed. Continuous update. The request animation frame loop in detect and draw ensures that the canvas is continuously updated with the latest eye tracking results in sync with the video frames. Transparent canvas. By removing the fill style from the draw bounding box function and no longer clearing the entire canvas, the canvas will only contain the bounding box, landmarks, eyes and triples drawn on top of the video feed, making it appear like it is drawn on top of the video and not obscuring the video. Click through canvas. This line makes the canvas transparent to mouse events, so you can click through it to control the video player underneath, e.g., pause, play. Live update. The use of request animation frame in a loop within detect and draw ensures that the canvas is redrawn for every video frame. This creates the live update effect. Now, the tracking canvas should overlay the video perfectly, be transparent except for the drawn elements, remain on top of the video, update in real time along with the video.
Those are some good prompts, aren't they? This, yep, actually could know. I'll pop that. Okay, let's see. Main.js. Load. Video element, yes. Should not be constant, is it? Yeah, because a canvas ID. Where do we have it? The video container style relative, position absolute, canvas style absolute. Sure, the canvas is on top. Don't really need the canvas click through, whatever. We're not clicking on it really. A video element play, detect and draw. Where's the updating live bit?
Continuous update. The request animation frame loop in detect and draw ensures that the canvas is continuously updated with the latest eye tracking results in sync with the video frames.
Yeah, this is one funny thing about the Gemini. It seems to not generate everything. Kind of kidding. Maybe it's just because I got used to a Copilot so much. Quest animation frame. $10, and they are not related, are they? They only have the one frame. Only one frame. Why? So that's some sort of circular thing over there. Okay, let's do HTML first and then JavaScript. Change the order. Change the order while it's generating. Go check out biomedical.com. There are a lot of interesting tools and blogs that you might find interesting or not, but do let me know what you think.
Yes, you've got it exactly right. The main JS you provided incorporates the necessary changes to ensure the tracking canvas behaves as desired. pen_spark. Overlay. Both the video and canvas elements are absolutely positioned within the video container, ensuring they overlay perfectly. Transparency. The canvas is made transparent to mouse events using canvas. Style. Pointer events equals none, and the clear rect function in drawing utils. JS ensures that only the current frame is rendered and the previous frame is cleared, making sure the video is visible through the transparent canvas. Z-index. The canvas has a higher Z-index than the video, guaranteeing it stays on top. Live update. The use of request animation frame creates a smooth live update of the canvas with each video frame. Minor clarification. The line video element, style, Z-index equals 0, ensures that the video is behind the canvas, not the other way around. Additional tips. Performance. You might want to consider optimizing the detect pupil function further. It currently performs calculations for each pixel within the eye region. Depending on the video resolution and frame rate, this might become computationally intensive. You could potentially use a low resolution image or subsampling to improve performance. Feel free to ask if you have more questions or need further refinements.
Auto updating is like a browser thing. Yerps.
The detect and draw function is called recursively within a request animation frame loop. This means it gets executed for every frame of the video, ensuring that the canvas updates as frequently as the video. At the beginning of each detect and draw call, the canvas is cleared using Clear Canvas, CTX, canvas. This removes any previous drawings, making way for the new eye tracking results to be drawn on top of the updated video frame.
It's not clearing.
The code inside detect and draw processes the predictions from the blaze face model. It then uses the draw bounding box, draw landmarks, draw eye, and draw pupil functions to redraw the relevant elements based on the current video frame and the detected facial landmarks. Additional considerations. Performance. If you find that the tracking is not smooth enough, you can potentially optimize the detect pupil function further, as it's doing pixel level calculations. You can also experiment with different frame rates or resolutions for video. Accuracy. The accuracy of the eye tracking can be influenced by several factors, including lighting conditions, camera quality, and individual differences in eye features. You might need to fine-tune the parameters in the detect pupil function, e.g., darkness_threshold, to get the best results for your specific use case.
Canvas is not updating. Help, help.
Conversation with Gemini. Hash this is app.py file for Flask app. Hash Flask app initialization and basic routing. From Flask import Flask, render _template. App equals Flask.
What are you talking
I'm unable to process images that contain people. However, I can extract the text from the image and identify some of the objects and read them in the image. The text in the image discusses a webcam eye tracking system that utilizes TensorFlow, JS and Blaze Face for landmark detection. It mentions key features such as dynamic adjustment of parameters and the system's ability to detect eye movements.
Come on.
Additionally, it seems there's an issue mentioned where the tracking canvas is not updating. Pen_spark.
Okay, I'll have to finish in a bit. Obviously, it's not happening for us at the moment. Get rid of the image. Snow. Forget about the image. should ignore. No. Ignore the image. I can't delete it. See the interface. What is it generating? Yes, silly goose. Anyway, we need to go. Check out the. We have live going on. Simulation. Go check it out. I already shared the link in the chat. I'll be taking a break. I'll see you in a bit. So hopefully it works better. Yeah, we can leave it empty. We have the drawing utils. We have the audio. A video stream. If face model. And face detection. We have the info and the Flask app. In the main.js. And let's see if it picks up on any issues with that. It's generating for quite some time.
Absolutely. Let's refine your code to ensure the tracking canvas behaves exactly as you need. Key improvements. Optimized canvas styling. The canvas styling is moved directly into JavaScript to avoid external dependencies and guarantee precise overlay. CTX, Global Alpha is used to control the overall transparency of the canvas, allowing the video to show through. Simplified drawing. Drawing functions now accept Global Alpha as a parameter to adjust transparency as needed. This eliminates the need for repeated calls to CTX, Global Alpha before and after drawing. Clear canvas on each frame. The canvas is cleared at the beginning of detect and draw for each frame to prevent residual drawings. This ensures that only the current frame's results are displayed.
Yeah, that's an important bit. Yeah, all those imports can Then we have position, canvas, start position absolute 001, global, set initial canvas transparency. The transparency is fine.
In drawing utils, JS, we add a new parameter global alpha to the drawing functions to control transparency of the drawn elements in case you want to experiment with their opacity. Each drawing function temporarily sets CTX, global alpha, and resets it back to its default value afterwards. In main, JS, the CTX, global alpha equals 1 is used in the clear canvas function to ensure the canvas is cleared completely on every frame.
Yeah, it's not doing the show the canvas complete in on every frame. Well, it's not the drawing then. It's not clearing, not drawing, not nothing. It's almost like 360 lines of code, comments included. Yeah, I'll try Copilot. That's relatively long. The video need to call the detect and draw. Inside the request animation frame. This will ensure the function call before the browser performs the next repaint, allowing canvas to update in real time. Detect and draw, request animation. In the main function after the video starts playing. This setup ensures that the detector scroll repeatedly, causing the tracking apps to update in real time along with the video. That's not happening. Only one frame is visible. How to fix? Now that's fine. That's not what the problem is. Bring the big guns again. See if it can fix anything.
Absolutely. The issue you're facing, where only one frame is visible on the canvas, is likely due to how you're handling the detect and draw function within the request animation frame loop. Let's modify this to ensure continuous rendering.
Detect and draw. Yeah, ensuring video metadata is loaded before processing. Yeah, we're adding a loop. Yeah, clearing the canvas, that's fine. Quest animation frame. Wait, and format document. Okay, we have the text image frame. Okay, I might be having trouble integrating. Like some sort of text and draw should have a loop in it. What?
Continuous loop. We've introduced an inner loop function within detect and draw. This function will be called recursively within request animation frame, creating a continuous loop that keeps the canvas updating. Clear canvas on each frame. Before drawing anything new, we call clear canvas, CTX, canvas, to erase the previous frame's contents. This is crucial to avoid the canvas displaying only the first frame. Request animation frame placement. The request animation frame, loop, call is now placed inside the try block, but outside the for loop. This ensures that a new frame is requested even if no faces are detected in the current frame. Explanation. By encapsulating your detection and drawing logic within a self-calling loop function, you ensure that the browser continues to request new animation frames, effectively updating the canvas with each video frame. Clearing the canvas on each frame prevents old drawings from persisting. Important considerations. Browser compatibility. Request animation frame is a standard browser API, but older browsers might require polyfills. Performance. If you encounter performance issues, you might need to optimize the detect pupil and drawing functions for efficiency. With these changes, your tracking canvas should now update smoothly in sync with the video, providing a continuous real-time display of the eye tracking results.
Yeah, we still might be having trouble integrating the changes, so we have to ask for the whole code. Detect and draw. It's working. I think I might have just forgot to a bracket or something. There was no error. The linter didn't indicate anything as well. Okay, so it's working again. It was yeah, we removed the separating between the two canvas, the video and the eye tracking canvas. Like 50, what's that, 0.5? Okay, we're back in business. Yeah, that 0.5 global. Okay, it's updating. Okay, now. That that's fine. Looks it's overlaid. Okay, there's a bit of a delay. Remain on top of the video. What sets? A CTX Global Alpha. Let's try 0.9 for a sec. Didn't make much difference. Why? Yeah, because we yeah, can we get rid of it? Like all of it? Right. Yeah, that's how it used to be before. I kind of got used to it, so that's still yeah, the algorithm is working in the same way as it used to. And that should be fine. The text there. Yeah, we need to check it on the phone because I found that yeah, those errors are fine, I think. Yes, when you check on the phone, it's not always what you see here, is not always what you get. On the on actual phones, we'll have to deploy and actually test. I don't know if it's someone on YouTube was recording a video using this as well, and they had the same problem where the canvas was misaligned. Double check, triple check. The video and tracking canvas. a video tracking canvas are aligned perfectly. Yeah, because the eyes. Yeah, it's important for the eyes. So I did pretty well, Gemini Advanced, and they are kind enough to provide, was it 2 months? I think they give a free trial for 2 months for the advanced. So far, I haven't also run into any timeouts, and that's a good sign. I might leave that code, but just comment it out, it's fine. Yeah, hopefully it picks up on that last prompt, as it should. Yeah, we need to check it on the phone.
Absolutely. Let's refine your code to create a seamless, real-time webcam eye tracking experience with the features you outlined.
Mind changing it again. Yeah, we're using Blazeface and TensorFlow.js. Okay, why are you waiting? Styling.
The HTML sets up the video and canvas elements and ensures they take up the same space for proper overlay. The CSS establishes transparent background for the canvas, always keeps the canvas on top, and also makes it click-through to avoid interfering with any video controls.
There are no video controls, what are you talking about?
CSS in HTML. The essential CSS is moved to the HTML for more streamlined structure. Aspect ratio. The video dimensions and canvas dimensions are calculated dynamically to match the aspect ratio of the camera feed. Global alpha. The initial transparency of the canvas is set in JavaScript so it can be adjusted easily in the future. Overlay. The video container's positioning is set to relative, and both the video and canvas elements are set to absolute with top left positioning for the perfect overlay.
Yeah, I suspect that top left absolute positioning might be a problem for mobile. Could this be a problem on a smaller mobile screen?
You're absolutely right. Using absolute positioning for the overlay can cause issues on smaller mobile screens where the video might not scale properly to fit the entire screen. Let's revise the approach to create a responsive overlay that works well on all screen sizes, including smaller mobile devices. Explanation of changes. Video container. Width, 100%. The video container now takes up the full width of the screen, adapting to different screen sizes. Height, 0, padding bottom, 56.25%. This combination creates a responsive aspect ratio for the container, 16:9 in this case. You can adjust the padding bottom value to match your video's aspect ratio if it's different. Video and canvas. Object fit, cover. This CSS property is added to the video element to make sure it fills the container while maintaining its aspect ratio. It prevents the video from being stretched or distorted on smaller screens. How it works. The video container dynamically adjusts its width to fit the screen. The padding bottom trick maintains the desired aspect ratio for the container, preventing the video from being distorted. The object fit, cover, property ensures that the video fills the container while preserving its aspect ratio, even on smaller mobile screens. The canvas automatically matches the size of its parent container, the video container. Additional tips. Aspect ratio. Double check that the padding bottom in the CSS matches your video's aspect ratio to avoid any stretching or cropping issues. Mobile testing. Thoroughly test on various mobile devices and screen sizes to ensure everything looks and functions as expected. Overflow. If you encounter overflow issues, content spilling out of the container, you might need to add overflow, hidden, to the video container's CSS.
Yeah. There's a modify response button. You can turn it into simpler. Yeah. Let's see how it. Yeah, we don't currently have a CSS, so we don't have a separate CSS. We have a CSS for the entire project, so all the styling should be in HTML or JavaScript, which is fine. I thought we don't want this to be 100. It gave me like generic stuff, ignoring everything else.
Video. Width, 100%. Height, auto. This lets the video scale proportionally to fit its container while maintaining its aspect ratio. Canvas. Position, absolute. Top, 0. Left, 0. This positions the canvas directly on top of the video element, covering it completely. No need for the padding bottom trick to maintain aspect ratio. No need for object fit, cover, on the video. The CSS is more concise and easier to understand. Important considerations. If you have elements after the video container, you may have to set a height of the video so they won't be hidden behind the video.
Yeah, that's why is that not just happening? Like, why do I need to do it manually?
In the current CSS setup, the video container's height will expand dynamically to maintain the video's aspect ratio. This can cause issues if there are other elements placed after the video container, as they might get pushed down or hidden behind the video. Here's a modified CSS approach to address this. Explanation of the changes. The hashtag video container now has the position relative property, which establishes it as a reference point for absolutely positioned child elements within it. The object fit cover property is added to the video so it maintains its aspect ratio even when being resized. The display lock is added to the video and canvas in order to solve the issue of the margin collapse so that they are rendered properly. With these changes, the video will adjust its height while maintaining its aspect ratio, and the max height, 100%. Ensures the video never becomes taller than its container. The object fit cover property is used to ensure the video fills the container while maintaining its aspect ratio, so it might cut out some parts of the video. There are other values to the object fit property that might be useful to you. Additional considerations. You can replace the max height property with a fixed height of the video, for example height 300px, if you want to have a fixed height video and want to prevent any part of it from being hidden behind a container. You may want to add some padding or margins to your hashtag video container to provide some visual separation between the video and other elements.
We removed the canvas separation thing. Pushed all code into single JavaScript. Yeah, we did other things. Okay. Let's deploy and check on mobile. Yeah, so the website will be down for like 10 seconds or so. Yeah, well, also, what else were we doing? Yeah, we're doing the cochlea simulation thing. Let's see why did we left? Yeah, that won't let us run because port 500 is already 5000 is already being used. Let's close it for a sec. Let's try again. Right, this one requires the start button. No errors, there's some warnings. Third-party cookie will be blocked. Yeah, cookie business. The cookie monster business. Yeah. Yeah, we had this problem. Where every time you hit this button, you had a new set of controllers added, which is obviously wrong. And then we also need to check how the electrode activation is actually working. The site is back online. Yet that's the updated version. And we need to check it on the phone. If you can check it for me, it would be great. I'll put the link in the chat. Yeah, it's wrong. It's still not correct. So it depends on your... I don't know how to fix it. And it's definitely doesn't look like what you have in here. No, no, no. It's really bad. Something really bad. Something's really wrong. The ad is also overlaid on top of it. Yeah. So many problems. Why the bot can't just fix it? Yeah, this interface is not great as well, is it?
Enhanced features and improvements. 1. Interactive frequency bands. Allow users to adjust the number of frequency bands, electrodes, using a slider. This would let them visualize how different implant models with varying electrode counts interpret sound. 2. Dynamic band display. Visually represent the selected frequency bands within the cochlear spiral, possibly using arcs or highlights that change color with amplitude. 3. Adjustable frequency range. Let users control the overall frequency range, e.g., 20 Hz to 20 kHz, to understand how different individuals might perceive sound with a cochlear implant. 4. Sound library. Provide pre-recorded sounds, speech, music, environmental noises, to demonstrate how a cochlear implant processes different audio inputs. 5. Real-time filter visualization. If you implement filters, visually show their effect on the frequency spectrum in real time, e.g., using a separate graph or by shading filtered areas on the audio canvas. 6. Tooltip information. When a user hovers over an electrode, display a tooltip showing the corresponding frequency range and amplitude. 7. Educational content. Incorporate more detailed explanations about cochlear implants, their function, and the science behind them. You could use interactive elements like expandable sections or pop-up diagrams. Refined code structure, main, JS. Additional considerations. Filter cutoff frequencies. You can start with default values that roughly correspond to a standard implant's range, but allow users to experiment. Smoothing. Implementing additional smoothing for the energy calculation and color transitions can make the visualization smoother and more visually appealing. Example UI enhancements, index, HTML. Key messages for educational content. Cochlear implants are not a cure for deafness but can provide significant improvements in hearing and speech understanding for many people with severe to profound hearing loss. The success of a cochlear implant depends on various factors, including the age of implantation, the duration of hearing loss, and the individual's motivation and rehabilitation efforts. The sound quality from a cochlear implant is different from natural hearing. It can take time and training for the brain to adapt to the new electrical signals. Let me know if you'd like help implementing any of these features or have more questions.
The problem is that the code for creating the filter checkboxes and sliders is inside the Start button's event listener. Each time the button is clicked, this code executes, creating a new set of controls. To fix this, move the code that creates the filter controls outside of the event listener, so it only runs once when the page loads. Here's the adjusted main.js code. Filter control creation. The code for creating the filter elements is now outside the Start button event listener and fetches them from the HTML file instead of creating new ones. Filter control event listeners. The event listeners for the filter controls remain inside the Start button listener because they need to update the filter connections after the audio context is initialized. There are a few errors and adjustments needed in the code. Let's walk through them and make the necessary fixes. The audio context is being used before it's initialized. You should move the initialization of audio context inside the Start button event listener to ensure it's ready when the button is clicked. Let's simplify the code by removing the filter functionality. This will streamline the code and focus on the core audio visualization and electrode color mapping. Remove the filter variables and functions. The variables related to the filters, low-pass filter, high-pass filter, low-pass checkbox, etc., and the update filter connections function are completely removed. Direct connection. Inside the Start button event listener, the audio source now directly connects to the analyzer, bypassing any filter nodes. Remove the filter controls from your index.html file within the filter controls div. Welcome to the Cochlear Simulator. This is a cochlear implant simulator designed to help you understand how they work. A cochlear implant is a device that can help people with severe hearing loss by sending electrical signals to the brain. To use this application, click the Start button. You will see a visualization of the electrical signals being sent. The cochlear-shaped display will show a rainbow gradient based on the audio frequencies. This application is for educational purposes only. It is not a substitute for professional medical advice. Welcome to the Cochlear Simulator. This is a cochlear implant simulator. It is designed to help you understand how cochlear implants work. A cochlear implant is a device that can help people with severe hearing loss. It works by sending electrical signals to the brain. This application will help you understand how these signals are sent. To use this application, click the Start button. You will see a graph that shows the electrical signals being sent to the brain. You can adjust the frequency and amplitude of the signals using the sliders. You can also adjust the number of electrodes that are used to send the signals. Try different settings to see how they affect the signals. This application is for educational purposes only. It is not a substitute for professional medical advice. If you have questions about cochlear implants, please talk to your doctor or audiologist. Key features: cochlear spiral. Electrodes are arranged in a spiral shape, mimicking the cochlear structure. Centering. Electrodes are centered within the pixel canvas. Rainbow gradient. Electrodes change color based on frequency band amplitude using a smooth rainbow gradient, blue for low, red for high. Inline styling. All CSS properties are directly applied within the JavaScript for self-contained solution. Frequency response. The frequency response of the audio visualization is divided into bands, each corresponding to an electrode. The amplitude of each band is calculated and mapped to a rainbow gradient color. The rainbow gradient ranges from blue, low amplitude, to red, high amplitude. The color of each electrode reflects the average amplitude of its corresponding frequency band. Electrode positioning. Electrodes are positioned in a spiral shape, resembling the cochlear structure. The spiral shape is achieved by calculating the angle and radius for each electrode. The electrodes are evenly spaced along the spiral, creating a visually appealing layout. Audio visualization. The audio visualization is displayed on the canvas element. The canvas is cleared before each frame to prevent overlapping bars. Each bar's height corresponds to the amplitude of a frequency band. The bars are colored using the rainbow gradient based on their amplitude. User interaction. The Start button initiates the audio visualization and microphone access. The audio visualization updates in real time as the microphone captures sound. The user can observe the changing colors of the electrodes in the audio visualization. Sound analysis. The audio data is captured from the microphone using the Web Audio API. The data is processed by the analyzer node to obtain frequency amplitude values. The frequency data is divided into bands, each corresponding to an electrode. Apologies for not being explicit. Here's a breakdown of the main changes made to the code. HTML, index, HTML. Filter controls. Added checkboxes, low pass checkbox, high pass checkbox, enable, disable filters. Added range inputs, low pass slider, high pass slider, to adjust filter cutoff frequencies. Added less than span greater than elements, low pass value, high pass value, to display the current filter values. Simplified the layout by using a single filter controls div. Styling. Added basic CSS to the less than style greater than tag in the head to center elements and provide visual separation. JavaScript, main, JS. Filter functionality. Filters created, low pass filter and high pass filter are now created using audio context, create byteboard filter. Filter connections. Filters are connected in series between audio source and analyzer. Filter value updates. The update filter values function handles updating filter values and display when the checkboxes or sliders are changed. Filter application. In draw, the frequency data from the analyzer is filtered before being used for the visualization and electrode color updates. Energy smoothing and normalization. Total energy and maximum band energy are calculated in each frame to ensure dynamic adaptation to audio levels. The energy ratio for each band is normalized using the maximum band energy, making the visualization more consistent. Color mapping. The color mapping for both the audio visualization bars and the electrodes now uses a blue to red, 240 to 0 hue gradient, reflecting high energy as red. Overall improvements. User interface, clearer filter controls and a more visually appealing layout. Filter implementation. Filters are correctly implemented and dynamically adjust to user input. Visualization accuracy. The visualization more accurately reflects the filtered audio data and the energy levels of each frequency band.
Okay, this is actually working quite well. Yeah, Gemini was able to do quite a bit. So the original filter is filtering 20 hertz, 1. Yeah, now I can see, can remove. Oh, why? Yeah, if those are selected, should gray out. Yeah, we don't have white. Yeah, still have to hit the start button for it to work. But yeah, this black color is okay. It's nice. It's one of the colors for the project. Let's read this again.
Filter controls. Added checkboxes, low pass checkbox, high pass checkbox, enable, disable filters. Added range inputs, low pass slider, high pass slider, to adjust filter cutoff frequencies. Added less than span greater than elements, low pass value, high pass value, to display the current filter values. Simplified the layout by using a single filter controls div. Styling. Added basic CSS to the less than style greater than tag in the head to center elements and provide visual separation. JavaScript, main, JS. Filter functionality. Filters created, low pass filter and high pass filter are now created using audio context, create bypod filter. Filter connections, filters are connected in series between audio source and analyzer. Filter value updates, the update filter values function handles updating filter values and display when the checkboxes or sliders are changed. Filter application, in draw, the frequency data from the analyzer is filtered before being used for the visualization and electrode color updates. Energy smoothing and normalization. Total energy and maximum band energy are calculated in each frame to ensure dynamic adaptation to audio levels. The energy ratio for each band is normalized using a maximum band energy, making the visualization more consistent. Color mapping. The color mapping for both the audio visualization bars and the electrodes now uses a blue to red, 240 to 0 hue, gradient, reflecting high energy as red. Overall improvements. User interface, clearer filter controls and a more visually appealing layout. Filter implementation. Filters are correctly implemented and dynamically adjust to user input. Visualization accuracy. The visualization more accurately reflects the filtered audio data and the energy levels of each frequency band.
1, 2, 1, 2. So the what's the range for that microphone? Is very sensitive. One, two, 1, 2. Yeah, so now I get more activation throughout the cochlea. 1, 2, 1, 2. 1, 2, 1, 2. Yeah, I'm not sure what the default settings should be. What are they? 20 hertz? No. Okay, let's do 100 or so. It's 20k. Let's do 15. This way we could actually check with how good or bad this microphone is. Yeah, you get a bit of this background noise. Yeah, it's jumping quite a bit. I suspect there's something wrong. Is there something wrong? Is there something wrong with the high pass particularly? It's just the ambient noise coming through the mic. But it's looking pretty good. Might need to update the description and publish this thing. Let me know what you think. Yeah, I still have to fix this one. There's a few problems. Go check out biomedical.com. There's a lot of interesting tools. And do provide your feedback. You will be helping the project a lot by visiting the website and providing your feedback. I can actually do something about it.
Absolutely. It's definitely possible to add an option to switch between a spiral and a linear, one-dimensional arrangement for the electrode array visualization. Here's how you could modify the code to achieve this. 1. Add a toggle button or drop-down. In your HTML, add a button or drop-down menu to let the user choose the layout. 2. Modify electrode positioning functions. Keep the existing spiral_electrodes function. Add a linear_electrodes function to calculate positions in a straight line. 3. Update create electrode in the main loop. Modify create electrode to take an X, Y position directly. In the main electrode creation loop, use the appropriate function based on the selected layout. Key improvements. Flexibility. Users can easily switch between visualizations, enhancing the educational value. Conciseness. The code remains clean and readable. Responsiveness. Electrodes are repositioned dynamically when the layout is changed. Additional considerations. Normalization. Consider how you might want to normalize the spacing between electrodes in the linear layout. This would make comparisons between the layouts more meaningful. Animation. You could add a smooth transition animation when switching layouts for a more polished user experience. User interface. Explore different ways of presenting the layout option, toggle button, radio buttons, etc., to best suit the overall design of your simulator. Feel free to ask if you have any further questions or would like to refine this implementation.
In the main electrode creation loop, use the appropriate function based on the selected layout. Flexibility. Users can easily switch between visualizations, enhancing the educational value. Conciseness. The code remains clean and readable. Responsiveness. Electrodes are repositioned dynamically when the layout is changed. Additional considerations. Normalization. Consider how you might want to normalize the spacing between electrodes in a linear layout. This would make comparisons between the layouts more meaningful. Animation. You could add a smooth transition animation when switching layouts for a more polished user experience. User interface. Explore different ways of presenting the layout option, toggle button, radio buttons, etc., to best suit the overall design of your simulator. Simplified layout management. The update electrode layout function now handles both the creation and positioning of electrodes for both layouts. This makes the code clearer and easier to understand. No redundant array. We no longer need the electrode positions array to store positions separately. The positions are calculated directly within the loop. Reduced global variables. Fewer global variables are used, which makes the code more maintainable. Drop-down menu. Replaces the toggle button with a drop-down menu for better user experience. Concise layout function. The update electrode layout function now efficiently creates and positions electrodes based on the selected layout, eliminating redundant code. Current layout variable. Stores the currently selected layout for use in update electrode layout function. Okay, here's the code with the layout selection removed and the code regenerated to only display the spiral layout. Removed layout toggle. The button and associated event listener for switching layouts have been deleted. Simplified electrode creation. The electrode creation loop is now solely focused on the spiral layout calculation.
Yeah, it's working more or less or more. Yeah, I wanted to have both arrays, the spiral and the continuous one as well, like stretched out array. But the on the pixel canvas, I wanted both arrays to be displayed, the continuous one and the spiral one that we currently can see. I'll have to continue this next time. Don't forget to check out the website, lots of interesting tools and blogs. Do let me know what you think, if anything's broken, any complaints. This is a good time because it's all under development. Yes, it is the same. H2. Didn't quite get that message, but okay.